Eugene asked, talking about angles, can you expand a little bit on your previous comment on the position of the mounted LiDAR versus IMU?
Sure.
Yeah.
So the position of the mounted LiDAR versus IMU really comes into play when you are doing the sensor fusion. So when you're trying to take the LiDAR and do some sort of time synchronization with the LiDAR and the IMU to create, to stitch together a bunch of LiDAR scans to create a full point cloud. So knowing that sort of translation as well as that angular rotation is really important.
Right, so we need to do the transformation from the local coordinate system of the LiDAR into the coordinate system of the IMU, and then later on in our stack we translate that into the coordinate system of the vehicle itself.
Mm-hmm.
And that's, basically how we need to register all the data sets together.
Right, and
which we're getting.
And that's a whole area too, because that transformation, if that rotation is a little off, or if you're manufacturing multiple units, for example, and the mechanics aren't perfect, and you're using a very hard-coded transformation value, you can get weird blur or effects in that outputted point cloud. And so there's some exciting things about kind of auto-calibrating that and doing that automatically. And we're going to get into that specifically in the third webinar.
Yeah, so the third and fourth episodes of the webinar series are dedicated particularly to pretty much this topic and how we fuse these sensors together to create a registered point cloud, continuously in motion from our vehicles.
Exactly.
We'll be providing sample IMU and GPS and LiDAR data from one of our data collection runs in one of our R&D vehicles.
Exactly.
We have a question here. Are you considering using the Vallejo Scala LiDAR with 4 beams? Not particularly for any sort of technical decision reasons. I think that's just been on our plate, something that we haven't yet looked into. The lowest laser count LiDAR that we've used is the Quantergy M8, and we've been able to get successful localization results with the M8. There's really no reason in particular that we haven't looked into it other than just bandwidth constraints and also cost reduction and us wanting to, go the direction of cameras, because we don't foresee LiDAR being necessarily, or at least we don't necessarily want to go with one particular type of sensor.
We want to focus on being sensor agnostic, and we do want to take input from LiDARs. So that's just another one that we could definitely try out.
Did you implement the function to load and create a map already for pure localization or expanding the map? I'm not sure I understand did you implement the function to load and create a map already? I think if you could expand on that question a little bit, we could answer that. I think in the repository itself, we are generating a point cloud, giving a sample packet capture file, and you can upload any sort of VLP16 packet capture file from that. So
we will have a demo video coming up shortly where we get data from the live LiDAR, run some of the code from this open source repository, and then actually visualize that in there.
Sure.